Okay, a video experiment on determining the IF frequency of this radio. Now, I think it's around 460, 465, and I want to try and calculate it from tuning the radio to a particular frequency, right? That is tuning it to a radio station, let's say at 1 megahertz with some AM modulation. And if we take that signal at 1 megahertz and we couple it, just passing through this coiled wire, it gets coupled loosely into the antenna coil that I'm using, and we can dial into the radio. You see that going past it? Okay, so that would represent tuning. Turn the volume down. Just turning the volume down on the radio. That would represent tuning to a station at 1 megahertz. Okay, switch that off. Now what I'll do is I'll change the coupling to a homemade little coil of wire here, and we'll connect the frequency counter and sniff the local oscillator frequency. The difference between the station and the local oscillator will be the IF frequency. Let's try that. Okay, so I've taken the same cable. I've just put in this homemade sniffing coil. It's a couple of turns between of an enameled wire across the connector. That cable is then plugged into the counter, which is just free running at the moment, 88 hertz or whatever it is. I'm going to reset it, and then we're just going to go and see if we can sniff the local oscillator from the radio down on those coils. Those coils there, those 4 coils you can see, occupy the local oscillator and the antenna coil for both the AM and the shortwave band. So there's 4 coils, local oscillator, antenna, AM, local oscillator, and antenna, shortwave. So I'm just going to push reset, okay, and let's see what I can get. So I'm going to go down here and just hold it loosely over the radio coils, not touching anything. And we're getting 1.473 megahertz. It's pretty good. There or thereabouts. So that looks like about 473 kilohertz is the IF frequency, because it's the difference between the local oscillator and the station, which we already said was at 1 megahertz. So what we'll try now is we'll try some different band settings. We'll change that to the bottom of the band and the top of the band and see if that local oscillator frequency tracks. Okay, at the top of the band, about 1.5 megahertz or 1500 kilohertz. I've got a small signal with a modulation of 400 hertz, and that's being coupled loosely through that coil into this antenna, and you can hear it, it's right there. Okay, so let's switch that off, and now sniff the local oscillator that's mapped to that frequency. Okay, probe swapped over. We got the cable ready. Gonna hit reset on the counter. 3, 2, 1. And let's sniff. Oops. Just careful, I'm not gonna touch my hand in there. It's 120 volts. Settling down at 1.9725 megahertz. So, okay, so we'll do the math. 1.9725. Yeah? Okay, so calculator. What did I say it was going to be? I'll do this through the camera. Let's clear that. Clear. 19725 megahertz. 1500 megahertz. Yep, 4.725, 4.73. Okay, let's try at the bottom of the band. Okay, at 550 kilohertz with the amplitude of a tone, we can hear it. There it is, again, coupled through the coil into the cable, and I'm right at the bottom of the band. That's the hard stop for the tuning capacitors all the way in. Let's just peek it. Okay, there. Well, let's go and measure the oscillator. Okay, and when I'm down at the bottom, sniffing the oscillator, I'm at 1023. Good enough, 1023, maybe 10235. 10235. Okay, let's try that. 10235. And then it's 550. Yeah. 473, give or take. So, local oscillator, 473 on the AM bands. Maybe we'll try the shortwave. 5.5 megahertz, coupled in. And commensurate with a higher frequency, I've had to make a different coil. Just a bunch of more turns, smaller they are. Get them into the local oscillator space. Not touching anything. And what do we get? Let's have a look. A little bit hard to work out. Seems like it's sensitive on this side, so let's try and get it in there. No. Let me get this. Maybe I should do it like that. Ooh, there you go. Coupled very nicely. 603, 6028. So from 5.5 to 6028. Well, that's not 475, is it? Okay. Something else? Let's do the math. What is that? 502, right? Interesting. Let's try. Yeah, it's about 502. All right, let's try the other side. Okay. 18 megahertz. And with a coupling, 17.7. Oh. Interesting. So it's, I don't know what to make of that. It's about 200,000 or 220. And it's running below